Alright, so this example is just about how to sketch a function. Honestly, normally we can just use our graphing calculator and sketch. Based on the graphing calculator, you can just follow and identify. So these are the following things that you must identify when you want to sketch a graph. Everything else can be look closely enough will be okay, but several information that we need to know the exact values. For example, the first one that we need to know is the x and the y intercept. So we know exactly when it cross x and y axis. We need to know sometime, not all the time because it's optional, is that any symmetry to see if any, so we can check for that. Also, we need to know the domain, which is also another optional. Not all problems that need to know about the domain because several problems is all real values, so there's no reason we need to figure that out. But some problem, for example, the one that whenever I see a fraction or a radical, or trig functions like tangent, that we want to check to see the domains to see where it's going and where it stopped. Number 4 is discontinuities. It's important that we know if there is any break, any jumps, any hole, any vertical asymptote. And then we also check for horizontal asymptote, oblique asymptote, which also that's the one that we have not go over, but I'm hoping that if there is time, then we can talk about oblique asymptote and use long division for it. Then recall that we also need to know which interval is increasing, decreasing by using first derivative test, determine relative max, relative min, concavity, and point inflection. So these are the key information that we need to check for before we sketch the graph. So hopefully you watch this example to help you with the last questions on your homework. Okay. Alright, so let's take a look at the given function. We have f of x is equal to 2 times x squared minus 9 divided by x squared minus 4. So first of all, several things we need to look for. Number 1. So we're going to follow the list. Is that number 1, we need to find the domain. So number 1, domain. Okay. The domain is we talk about where is the function, is there any restriction? So we look for the x values. When we talk about domain, we talk about the x values. So what values that x cannot be any restriction, or where it, from what point to what point. That's what we looked at. So the domain, to check for the restriction, in this case, I see a fraction, so I'm checking the denominator to see any problem with that. We want to know when it's undefined. So I'm using domain by look at the denominator. 1 is equal to 0 because we know if the denominator is 0, then it's undefined at that point. So we know the domain is x cannot be positive or negative 2, because if when we have those values, the function is going to be undefined. Okay, so second, we want to look for discontinuity. So we want to know when it's break, when the graph is break, like is there a jump, is there a hole. So we look at this one, we can see that if you recall, to determine discontinuity, we want to check to see if we can cancel. So we know that, oops, I'm sorry, I have no idea. So x squared minus 9, x squared minus 9 over, I apologize, okay, over, we just factor out the denominator, which is x minus 2, x plus 2. So in this situation, there is no term that we can cancel out. So that's saying that the discontinuity is there is no hole, but these two would give you a vertical asymptote because we cannot cancel this out. So we have vertical asymptote when x is 2 and negative 2. So there's no hole, there's no jump, but we have vertical asymptote. Okay. Alright, so the third thing that we're going to check is the x and y intercept. X-intercept, let's check that first. And then we also check for the y-intercept. Okay. So for the x-intercept, I'm going to check to see when y is 0. So y is 0, I set the function equal to 0, x squared minus 9 over x squared minus 4. So let's see, x is going to be equal to 2x squared minus 9. So x-intercept will be occur at positive and negative 3. We want to do the same for y-intercept. That is mean when x is 0. So if you plug in, so we're going to check y equal to when x is 0. So 2, 0 minus 9. Oops. So when 0 minus 9 over 0 minus 9 over 0 minus 4. So if we look at this one, I can see is 0 minus 9 is negative 9, so negative 18 over negative 4. If we reduce, this would give us negative 18 over 4, so that's going to be positive 9 over 2. So x-intercept going to be occur at 3, 0, negative 3, 0. And then y-intercept is occur when x is 0 and y is at 9 over 2 or 4.5. Okay, so that's the third one that we checked. Then we also check for horizontal asymptote. Horizontal asymptote. So this is the fifth one that we're going to check. We learned how to check for horizontal asymptote is that we, let's write the function again because I don't want to move the screen so that you can see x squared minus 4. So we learned how to find horizontal asymptote thinking about limit as approaching infinity. So if we look at this, is balance. So it's balance, and then the term, any term like constant, it will turn into 0, so we don't have to worry about that. But the coefficient, that's the one that we will use. So the horizontal asymptote going to be as y equal 2. Alright, so these are the key information that we're going to use later. Alright, so we got domain, discontinuity, vertical asymptote, horizontal asymptote, x and y intercept, and now we're going to use first and second derivative to determine increasing interval and decreasing interval. Then we look for identify max and min and concavity. One is one is concave up and one is concave down. So we will look at, sorry about that, I'm going to turn to the next screen. So we will look at first a derivative. So we want to determine if it's increasing or decreasing. So to determine increasing, decreasing, relative max or relative min. So we're going to use first derivative. Okay. So I'm taking the derivative of this one. F primes would be equal to this is quotient, what I would do is that I see the 2 in front of the coefficient, then I can just go ahead and factor out the 2, so that make it easy for me, so I don't have to deal with a big value. So I'm taking out that 2, and then take the derivative of what inside. So the x squared minus 9 and x squared minus 4, that's the one that I'm going to use to take the derivative. Okay. So this is a 2, that's the coefficient that I'm just going to factor it out as outside the function. So we can use, that would help us for the smaller numbers. Okay, so I'm taking the derivative, so that's going to be 2x times x squared minus 4. I'm going to erase this because I will probably need more space. Minus, so this is the first bracket, and this is the second one. The x squared minus 9 will stay the same, and then times 2x. And then the denominator is x squared minus 4 squared. Okay. If we're going to simplify, the 2 is still outside. If I multiply it in, it's going to be 2x to the third minus ax minus 2x to the third plus 18x. So I'm simplifying the numerator, x squared minus 4 to the second power. So this would be equal to 2 square root, I'm sorry, not square root. If I'm going to simplify this, it's going to be x squared minus 4 squared. And the top, if we cancel out, combine negative 8x and 18x, so that would give us 10x. And if we multiply in the 2, that can be 20x over x squared minus 4. So it's okay that we can multiply it in right now. So that would give us the f prime of x is this values. Right, so we're gonna find critical point. I would see that 20x equals 0, so one of the point will be 0. Then we also check for the denominator. So x squared minus 4 equals 0. So x squared equal to 4. So another point that we're going to deal with is plus or minus 2. Alright, so we will check our values. Okay, so the table, so we go from negative 2, 0, and then 2. So if we're going to check, we know this one, the interval is negative infinity to negative 2. We have negative 2 to 0. I write too big. Negative 2, 0, 0 to 2, and then 2 to positive infinity. So those are the interval. And then we can do a test point. Based on my test point, it's going to be negative, negative, and positive. Okay. So after we use our test point, we checked, and so for the space, we're not going to show a lot of work here, but I'm telling you, these are the information that after I calculate, this is what I have. So the first interval and the second one is negative, 0 to 2, and 2 to infinity is positive. So we can say that it's increasing from 0 to 2, and then from 2 to infinity. Okay, and we also know right here is we have a relative min at x is equal to 0. So increasing is from 0 to 2, and then 2 to infinity. decreasing is from negative infinity to negative 2, negative 2 to 0. Okay. Alright, the last one that we're going to look at is second derivative to find concavity to see one is increasing, one is decreasing. So second derivative, if we take second derivative, because of space, I'm about to run out of space, and we know how to take derivative of this one. So if you take derivative second, if you need to review how to take derivative, second derivative from the given information, then we can review that. But the one we're taking the derivative right now is 20x over x squared minus 4 in parentheses to the second power. So that means x squared minus 4 to the fourth power, because 2 to 2 is 4. And then on the top, I would have, if I simplify everything, I should have negative 20 times 3x squared plus 4. Okay. To the second, sorry, not the second, 3x 4, and then with all the work that I have done, that would get me to the third power. So for those like, why is it a third, you feel free to ask me, and then I can show you on a separate piece of paper. Like I said, this is all the space that I have left to write, and so I'm going to save some space for that reasons. So now we're going to find point of inflection. Point of inflection by set the second function equal to 0. So by set it that equal to 0, I have negative 20, 3x squared plus 4 equals 0, and then I cannot find any solution for this one, because after I minus 4, that's negative 4 over 3, and then if you take square root of a negative, it's just an empty set, so there's no real solution right there, so there is no point of inflection right here. But we also want to check for the denominator, so x squared minus 4 equals 0, so x squared is equal to 2, positive and negative 2. So we can say that there's no point in inflections. Pretty much whatever the interval that would give you the inflection going to be the same right here, but we have negative 2 and 2. So we're going to check the interval at negative 2 and then 2. So our interval negative infinity to negative 2, negative 2 to 2, and then 2 to past infinity. And if we checked our values, it's going to be negative, positive, and negative. And so this will tell you one is concave up and one is concave down. Concave up is from negative 2 to 2. Concave down from 2 to infinity, and from negative infinity to negative 2. So those two intervals will be concave down. Alright, so what I would do now is that I'm going to go back to the first screen that we have with the graph. I didn't think of that. I should have the graph at the very end, but that was my fault. I didn't think of that. So now I'm going to go to the first. So what you need to do is go back to the coordinate plane, and we're going to sketch our graph. Okay. So several things that that we should remember is the y-intercept is about 4.5. So I would plot that point right there. And then the x and the y-intercept is at negative 3 and 3. Right. So that is the 3 key points that we're going to have the exact values. Then we know that we have a horizontal asymptote at 2. So I make a dotted line at when y is 2. Then we also know that the vertical asymptote is at -2 and 2, so that's going to be vertical asymptote. So I'm going to draw that, okay? And then we go back and we, as recall, is increasing and decreasing from where? So it's decreasing from -infinity to -2. So decreasing, I'm going to use a different color. So it's decreasing from -infinity to -2 and concave down. Okay, so we have that decreasing and concave down. And then from -2 to 2 is, that's, if you remember, we also have a 0 for first derivative. Is that we know that from -2 to 0 is decreasing and is concave up based on our second derivative. So we're going to have this chart again. So -2, 0, and 2. Okay, so I'm going to label the chart just to remind ourselves: decreasing, concave down, and from 0 to 2 is decreasing but concave up, and then increasing and concaved up as well, because there's no chain of concavity at 0. And then the last one is increasing but it's concave down, based on our test, the first and the second derivative that I put together in one place right here, just so that we see it. Right, so we can go ahead and sketch decreasing and concave up, and then increasing and concave up. And then the last P is increasing and concave down, so this is what we will have. So that's how we sketch the graph. Honestly, we can use a graphing calculator, but there's times that they may ask us to identify or give a summary of analyze the functions. So this is the key things that we need to look for if we need to analyze the following function. For the function, I need to sketch a graph. So we need to know key information: when it's increasing, when it's decreasing, when it's cross x and y intercept, is there any break, is there any vertical and horizontal asymptote. Hope you enjoyed the video and hope this helped with your homework. You get to choose one of the two. So do the one that you feel comfortable, and then please come on Monday with questions, or you can post question at Modo. Ms. Conan and I will respond to your question as soon as possible. But we will talk about homework on Monday.